Hello everybody, my name is Andy Zhu, and today I'll be explaining the 1998 Calculus BC FRQ question number 3. So the problem reads, let f be a function that has derivatives of all orders for all real numbers. Assume that f of 0 equals 5, f prime of 0 equals negative 3, f double prime of 0 equals 1, and the third degree derivative at 0 equals 4. Now, part A asks us to write the third degree Taylor polynomial for f about x equals 0 and use it to approximate f of 0.2. Now, to do this question, we have to know the general form of a Taylor polynomial. So the general form of a Taylor polynomial is fn, or the nth derivative, times x to the n over n factorial. And in this case, it's about x equals 0, so then it's the nth derivative at 0. So we have all our information that we need here, so we can just write out what the Taylor polynomial would be. It'd be f of 0 at 0, so the 0th derivative at 0, times x to the 0 over 0 factorial, plus f1, 0, x to the 1 over 1 factorial, plus the second derivative at 0 over 2 factorial times x squared, plus the third derivative at 0 over 3 factorial times x cubed. Now, to do this, we'll just substitute our known values. We get 5 plus negative 3 x over 1 plus 1 over 2 factorial x squared plus 4 over 3 factorial x cubed, and we can just simplify this to 5 minus 3x plus x squared over 2 plus 2 over 3 x cubed. Now, to approximate f of 0.2, we can simply just substitute an x equals 0.2 into our third degree Taylor polynomial. So then we just get this equal to 5 minus 3 times 0.2 plus 0.2 squared over 2 plus 2/3 0.2 cubed. And this is equal to 5 minus 0.6 plus 0.04 over 2 plus 2/3 0.008. This is just approximately equal to 4.425. So this is our answer to part A. Now going to part B. Part B says, write the fourth degree Taylor polynomial of g, where g of x equals f of x squared about x equals 0. So then again, we can just use this Taylor polynomial that we had. So this is the Taylor polynomial, the third degree, which is 5 minus 3x plus x squared over 2 plus 2/3 x cubed. So this is f of x. And then g of x equals f of x squared. So just to get f of x squared, we can just substitute an x equals x squared. So this is kind of confusing, but it's very simple once you guys see it. So this is going to be 5 minus 3x squared plus x squared over 2 plus 2/3 x squared cubed. So what we just did here is, when there's an x here, x there, just substituting that x equals x squared, and this is equal to 5 minus 3x squared plus x to the 4th over 2 plus 2/3 x to the 6th. And so because part B asks us to write the fourth degree Taylor polynomial, we can ignore this part. So this is going to be 5 minus 3x squared plus x to the 4th over 2. And this is our answer for part B. Now, moving on to part C. Part C says, write the third degree Taylor polynomial for h, where h of x equals the integral from 0 to x of f of t dt about x equals 0. So we're just asked to find the integral from 0 to x of f of t dt. Now, we know that our polynomial here, 5 minus 3x plus x squared over 2 plus 2/3 x cubed, this is our Taylor polynomial, but we realize that it's asking for a third degree Taylor polynomial, and whenever you integrate something, the degree goes up. So technically we only need these three terms. We don't need this term because that would give us a fourth degree. So then this is just going to be the integral from 0 to x of, as it says here, 5 minus 3x plus x squared over 2. But instead of x's here, these should be t's, because we're doing dt. So this actually should be integral from 0 to x of 5 minus 3t plus t squared over 2 dt. And then we can simply just integrate this, and once we do that, we get 5t minus 3 halves t squared plus 1/6 t cubed from 0 to x. And then because all of these have a t, the t equals 0, the t equals 0, so we just have to subtract 0, so we can just substitute x, and we get 5x minus 3 halves x squared plus 1/6 x cubed. This is just our answer for part C. Now, part D, it says, let h be defined as in part C, as in the integral. Now, given that f of 1 equals 3, either find the exact value of h of 1, or explain why it cannot be determined. So we're simply asked to find the integral from 0 to 1 of f of t dt. Now, this seems like a pretty simple problem, but we don't have enough information to solve it. It actually cannot be determined. And this is just because we only know f of 1 equals 3 and f of 0 equals 5. We don't have, because we only know this, we don't have the entire polynomial of f. So technically we can only approximate the integral from 0 to 1 of f of t. We can't actually find the exact value, and it's asking for the exact value. So because of this, it cannot be determined. So this is 1998 Calculus BC FRQ number 3. And if you're having any trouble with these types of questions, these Taylor polynomial questions, you can either go into the book, which is chapter 11, and then in the later sections, 11.8, 9, 10, or you can look at similar FRQ questions and their explanations, and there will be a link below in the description. Thank you.